How's the day? Today we're going to be going over topic 17, which is about exponents. There are certain rules that we're going to work with. They're all listed here. We'll go over each of them in depth, but here's what they are, and let's just get started now on exponents. So if we were to have x raised to 4, in this we have a base of x. 4 is our exponent, and altogether this is called a power. And x raised to 4th is equivalent to x multiplied 4 times. And this works for numbers as well. So if we have like 2 raised to 3, this would just be 2 times 2 times 2. Moving on to some of the properties, some of the laws or rules of working with exponents. If I was to have x raised to 2 times x raised to 4. So whenever we're multiplying two powers that have the same base, again, we have the same bottom number here. They both have x. What we're going to do is keep the base and add our exponents. So this would be equal to x raised to 2 plus 4, which is x raised to 6. If I had something like 3 times 3 raised to 2, so 3 times 3 squared. When I'm doing this, if I ever have something with no exponent, it's understood to have an exponent of 1. So when I'm evaluating this, I'll actually make it 3 raised to 1 plus 2, which is 3 raised to 3. For this class, if ever you can figure out something, you're going to have to evaluate it. Basically, you can't leave your answer as 3 raised to 3. If it's a number raised to another number, you'll actually have to evaluate it. In this case, 3 raised to 3 is 3 times 3 times 3. And that is 3 times 3 is 9, times 3 is 27. So your answer for that one would actually be 27. It works as well for expressions. So if we had something like this, x squared y times x cubed y to the 4th, what I would do first is, okay, looking at this, I can already tell that I have a y raised to 1 there because there's no exponent. Now I'll just multiply each variable. So I'll have x squared times x cubed times y to the 1 times y to the 4th. From there, I'll just add my exponents. So this will become x raised to the 5th power and y raised to the 5th power as well. We always know that division is the opposite of multiplication, so it makes sense that if I was to add exponents when multiplying, you subtract when dividing. And this actually occurs because whenever you have a fraction, for example, if we had x raised to 5 over x squared, this actually just means x times x times x times x times x over x times x. And the reason that we're able to just subtract the exponents is because when you have something like this, these actually cancel out. So one of these will cancel one on the bottom, one will cancel one on the bottom. The same way we can cancel things whenever we're working with factors and simplifying fractions. So now I'm just left with 3 on the top, so I'm left with x raised to 3, and it's over 1 on the bottom, so you don't really need that. So if you were to have a raised to 4 over a raised to 1, this would be a raised to 4 minus 1, which is a raised to 3. 3 raised to 5 over 3 cubed would be equal to 3 squared. And again, we'll have to evaluate that. 3 times 3 is 9. Plus lastly, it works again for expressions. X squared y raised to 5 over x y cubed. I just subtract my exponents there. X raised to 2 minus 1, which is 1. Y raised to 5 minus 3, which is 2. If you want to put the 1 there, you can. Next, we'll look at the power rule, and this is when we have a power raised to another power. So for this, you'll actually keep the base and multiply the exponents. Looking at this first one, we have x to the third power, which we can also say x cubed, raised to 2. So it'll be x raised to 3 times 2, which comes out to x raised to 6. 2 squared raised to 3. So this one will actually multiply 2 and 3 again. 2 times 3, which is 2 raised to 6. Again, we'll have to evaluate this. 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5 times 2. The way I usually do it is I'll actually work on this on my own here. So I'll say, okay, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So this is actually equal to 64. Z to the fifth power raised to 2. This is going to become z raised to 2 times 5, which is 10. Next, we have the expanded or extended power rule. And this basically states that if you have an expression, like a product or a quotient within parentheses, and that's raised to an exponent, it basically tells you that that exponent will be applied to everything inside the parentheses. And this only occurs when you have a single term inside your parentheses. So it cannot be like x plus y. You don't just distribute it from there. Only if it's a single product or quotient. So if we have 2a raised to 3, this basically just means, okay, we have 2 raised to 3 times a raised to 3. We have to evaluate that 2 cubed, which is 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, a raised to 3. 6x cubed squared. So we'll have 6 squared times, now we're looking at, you can skip this step, but this basically is just x cubed squared. And we know that when we have a power raised to a power, we'll have to multiply the exponents. So this just becomes 6 squared is 36. X raised to 3 times 2, which is 6. A lot of times people will just jump straight to the 3 times 2 instead of doing x cubed raised to 2. But this just shows you that it's just distributed to everything in the inside. If you have something like x squared over y raised to 4, it'll just be x squared raised to 4 over y raised to 4. Again, this is a step that you can actually skip. You can just go straight to x raised to 2 times 4, which will become x raised to 8 over y raised to 4. Looking here, we have 2 raised to 3, x raised to 3 over 3 raised to 3, y raised to 2 times 3, which is y raised to 6. From here, 2 times 2, 4 times 2 is 8, so we have 8, x cubed. 3 times 3 is 9, times 3 is 27, y to the 6th. If I can simplify my fraction, cannot. 8 divided by 27, they have no common factors. That's simplified. Zero exponent rule. If you have any base that's non-zero, again, okay, so this occurs when a is not equal to 0. Any number, any base raised to 0, the 0 power is equal to 1. So if you had this, y raised to 0, if you had 6 raised to 0, or if you had an entire expression raised to 0. Since these are all raised to 0, this is actually all equal to 1. It's important to note that an exponent applies only to the factor it's directly next to, unless parentheses enclose in other factors. So if you had like 4x raised to 0, this would be equal to 1. But if you had 4 times x raised to 0, the 0 exponent's actually only for x in this point. So this becomes 4 times 1, which is 4. So that's the difference there. Now we're going to look at the negative power rule. So there's two different ways to have this. So if you have a number raised to a negative exponent, it's just 1 over that, but make it positive. This also works if we have a negative exponent in our denominator instead. So if it was instead 1 over a raised to negative x, so it's either that, 1 over a raised to negative x, that's actually equal to a raised to positive x. So it's important to note that a negative exponent does not affect the sign of an expression. It just affects the position of that variable or number. So if a factor in a number, the factor in the numerator or denominator is moved across the fraction bar, meaning to say it moves from the numerator to the denominator or the denominator to the numerator, the sign of the exponent is changed. So here we have x raised to negative 3. That actually just means that it's going to be positive on the bottom. So if right now it's negative in the numerator, it will be positive in the denominator. We do need that placeholder there, so it would be 1 over x cubed. If we have something like this, you can actually distribute it. So it's x raised to 2 times negative 3, which is negative 6, over y raised to negative 3. Now basically all I'm doing is moving wherever I have a negative exponent, I'll move it to the other side. So I'll move this down, and then I'll move this one up. And that's only because both of them are negative. So this actually becomes y raised to 3 over x raised to 6. Looking at this last one here, I'm just identifying anything I have here that has a negative exponent, and that will be moved to the opposite side. So we have A, C, and D. So A is going to move down, and everything else is going to move up. So both of these are moving up. So we have B raised to 3, C raised to 4, D raised to 1, all over A squared. You'll notice that B actually stays in the numerator. That's because it stays wherever it's positive. So I don't need to move it because it has a positive exponent in the numerator. Here we have a bunch of practice problems, which we'll go over. So what I like to do first is I try to simplify across and then cancel up and down. Here I don't need to simplify across because I cannot combine x and y, so I'll just multiply up and down or subtract up and down. So what I actually do is I cancel things out. We've went over it before, but x squared divided by x, I can see that the smaller one's going to be canceled, so x is gone. This will instead become x raised to 1 because it's 2 minus 1. Y raised to 4 is smaller, so that's out. This becomes y raised to 5 minus 4, which is 1. I'm left with x raised to 1 times y raised to 1, or simply xy. Looking at this next one, I notice that there's a negative exponent there. A good first step is to move any negative exponents so that they become positive, so you don't have to be working with adding or subtracting negative values, which I personally don't like to do. So what I want to do first is just rewrite this with only positive exponents. We have 2 x raised to 4 over 8 x raised to 7 y raised to 3, and now I have that y raised to 4 in the bottom. From there, I'll simplify across. So we have 2x raised to 4 over 8x raised to 7 y raised to 7. Now I'll be canceling things out in order to simplify. 2 over 8, that becomes 1 over 4. It's important to note when it's just numbers, these are not exponents, right? We just have 2 divided by 8. You simplify that normally. You don't just do 2 minus 8 or something like that. That's only when we have the same base, but exponents. X raised to 4, x raised to 7, x raised to 4 is gone. This becomes x raised to 3, y raised to 7 stays the same. So we have 1 over 4x cubed, y raised to 7. When you have something like this last one, what actually might be helpful is to simplify the interior first, so whatever's inside your parentheses, and then applying that exponent to it. So here I'll have 4 over 16. I can actually simplify that one, right? So that becomes 1 over 4. X raised to 5 over x. The x is cancelled. This becomes x raised to 4. Y is cancelled. This becomes y raised to 3. So we have x raised to 4 over 4 y raised to 3 raised to 3. From there, I'll distribute my exponent. Again, it also goes to the 4. So we have x raised to 4 times 3, which is 12, over 4 raised to 3 times y raised to 9, which is equal to 4 raised to 3 is 4 times 4 is 16 times 4 is 54, y raised to 9. You might also see like this. So usually whenever you're simplifying, you'll want to leave everything with positive exponents. So if we have this, you simplify, use only positive exponents. Again, I'll simplify the interior. So we have a raised to 1, b raised to 1 on the bottom, c raised to 0, that is just 1, so this stays 3, c raised to 3. So this is equal to negative 7 over 3, a, b, c cubed, all raised to negative 4. Now I'll distribute this negative exponent. Whenever you have a negative inside negative inside, so you'll have to keep it inside parentheses, raised to negative 4 over 3 raised to negative 4, a raised to 1 times negative 4, b raised to 1 times negative 4, c raised to 3 times negative 4, which is negative 12. And now, since all of these have a negative exponent, I'm actually going to change the place of everything. So everything on the top is going to go down, everything on the bottom is going to go up. So we have 3 raised to 4, a raised to 4, b raised to 4, c raised to 12 over negative 7 raised to 4. From there, I'll evaluate my numbers. So 3 raised to 4 is 3 times 3. 9 times 3 is 27, times 3 is 81. So we have 81, a raised to 4, b raised to 4, c raised to 12 over negative 7 raised to 4. This actually becomes negative 7 times negative 7 times negative 7 times negative 7. So that'll be a positive number. And this actually comes out to 2401. On the other hand, you might have a question that tells you to write without fractions. So basically, I want to move everything to my numerator. And again, whenever you move something across the decimal line, across the fraction line, what you're going to do is change the sign of the exponent. So when I move everything up, when I move this y to the top, I want to leave it in order. So x raised to negative 3, that's fine. Even though it's negative, I'll keep it on the top. When I move the y up, it becomes negative. When I move the z up, it actually becomes positive because it's negative on the bottom. And that's how you write it without fractions. You just move everything to the numerator. Now we're going to be working with negative numbers raised to exponents. So if you were to have negative 1 raised to 3, this means negative 1 times negative 1 times negative 1. If you have a negative number within parentheses raised to an exponent, it means that you're going to multiply that negative number to itself how many times? And if it's raised to an odd number, it would be negative, right? On the other hand, if I was to have negative 1 raised to 4, if it was raised to an even number, negative 1 times negative 1 times negative 1 times negative 1, they would essentially cancel out because negative times negative is positive, times negative is negative, times negative is positive. So if you had an even number of negatives multiplied, it would actually turn positive. So that would be positive 1. So negative raised to an odd number, negative, negative raised to an even number, positive. On the other hand, if you had something like negative 1 raised to 3 or negative 1 raised to 4, if it's outside parentheses, this exponent is actually only for 1, not for negative 1. So essentially this is just negative times 1 cubed. Like negative 1 times 1 cubed. Negative 1 times 1 raised to 4. So this, you'll actually be applying this negative sign after finding the exponent. So this would just be negative 1. This would be also negative 1. So keeping that in mind, I can actually look at this first one. When I have negative 1 in parentheses raised to 3, I know that's just going to be negative 1 over this on the bottom also becomes negative 1. So simplify, this becomes positive 1. For this one on the right, I actually don't even care what 3 raised to 4 is. Since it's the same, they're going to cancel each other out. But I want to look at the sign of it. So if I have negative 3 within parentheses raised to 4, since 4 is an even number, that's actually going to become positive 3 raised to 4. The bottom, since it's negative and there's no parentheses, it's going to be negative 3 raised to 4. I can cancel these out actually. 3 raised to 4 over 3 raised to 4. Anything divided by itself is 1. So this becomes 1 divided by negative 1, which simplifies to negative 1. Lastly, we have scientific notation. So scientific notation is used. It was developed in order to express either really large or really small numbers in an easier way. So without all the zeros. So if we look at something like 123,000, we want to express that with a few numbers. So whenever we have scientific notation, it's actually going to be written in the form like one number, point, whatever, times 10 raised to something. So you always want one number in front of your decimal place. So if I wanted to convert 123,000 to scientific notation, first step is to identify where the decimal place is. If there's no decimal place, it's understood to be at the end. So I have a decimal place right here, and I want to move it so that there's only one number in front of it. So I'm going to move it now to the left. So we have 1, 2, 3. Count how many times. I moved it 3 times. 4, 5. So I have to move it 5 times in order to get it in between 1 and 2. So I'm left with 1.23 times 10 raised to, and since I moved it 1, 2, 3, 4, 5 times, I'm going to put 10 raised to 5. And you can know whether to put raised to a positive exponent or a negative exponent based off of, okay, looking at 123,000. I know this is a really large number, so obviously I'm going to multiply it by something raised to a positive exponent. On the other hand, if you have a small number like this, a decimal where you have 0.00 something, this is going to be something times 10 raised to a negative exponent. So I'm going to do the same thing again. I'm going to move my decimal place and count how many times I move it so that there's only one number in front of the decimal. So we'll move it 1, 2, 3 now, because I only want that 1 in front. So I'm left with 1.732 times 10 raised to now the negative third power. I always suggest you look at it again after you write it. just to make sure, okay, this is a small number, negative exponent, large number, positive exponent. For the very last part, we're going to look at how to use scientific notation when performing operations. So for example, we have 400 times 500. This is something you know how to do, but for this topic, you'll have to know how to do it using scientific notation. So first step would be to convert each of them to scientific notation. So 400, that's going to be decimal point right there. Move it 2 times. That's just 4 times 10 raised to 2, right? Times, same thing, 5 times 10 raised to 2. From there, I can multiply my numbers. 4 times 5 is 20 times 10 raised to 10 raised to 2 times 10 raised to 2 is 10 raised to 4, right? When we're multiplying, we add our exponents. From here, you want to make sure that your answer is in scientific notation. This is not in scientific notation because I have 20. It should be 2.0. So you can convert it to number again. So I know, okay, this is 20 and then 4 zeros there. So I'm going to move it 4 times. Or I can say, okay, my decimal point is right here. I move it once, so I'm left with 2.0. And I'm actually going to add 1 over here because I moved it 1 more time. So I'm left with 10 raised to 5. And that's my final answer. You can check your work if you want. If it's something simple like this, okay, I'll say 400 times 500. That's going to be 0, 0, 0, 0, 20, 200,000. That's the same as that. You can do that, but it's not necessary. So that's it for this lesson. It's pretty long, but it'll be pretty easy once you do a little bit more practice. We've done a little bit of canceling, working with exponents in the beginning of the semester, so I think you should be okay.